Julia, you're from Germany.
Correct.
You trained as a biochemist at what I'm going to try and pronounce this, the Bayreuth University.
Yeah, Bayreuth. Yeah, it's hard to do. Yeah.
Thank you. I'll just leave your correction as it is. You went to Harvard and you graduated from the Harvard Medical School with your PhD. And I think we can all applaud that. That is no small achievement. So congratulations on that.
Thank you.
You've worked for a private pharmaceutical in the Bay Area called Cytokinetics. You spent about 11 years there before coming to UC Berkeley, where you are now the director of the Center for Emerging and Neglected Diseases, where we actually need to hear from people like you and what your perspective is on COVID-19 or emerging diseases as they are. And without taking the center stage anymore, I would just like to hand this over to you and ask you to tell us a few things that you are thinking about. So go ahead, Julia, take it away.
Thank you. Thank you, Andy, and the Rotary Club of El Cerrito for the kind introduction. I've always wondered who is in the Rotary Club and what do you guys do? So this is a great opportunity. I run a lot in El Cerrito Vista Park and spend some time there with my kids, and I always see the plaque of the El Cerrito Rotary Club there. So that's how I first learned about you. And glad to be here. So thanks for the kind introduction. I'll kick it off a bit talking about my center and what we do at UC Berkeley, how we've pivoted also in this pandemic to COVID-19. My center always has focused on emerging diseases, but in the past it was more on neglected tropical diseases that don't affect many people in the United States. And we were trying to get more research going on those because globally the morbidity is massive and also mortality. But since COVID hit, it was actually very funny. We have a yearly symposium that also moving forward, I'm happy to invite everybody. It's free. It's at UC Berkeley. And we do this normally in January. And we had our symposium on January 12th, 2020. And I had invited a whole group of people talking about Ebola virus. And in Ebola, there's also animal transmission. And so there's all these people who work on animal transmitted viruses. And they were in the coffee break talking about COVID. And this is the first time I heard about it because I hadn't, John Amazit from UC Davis, he was saying everybody must be worried about this coronavirus thing. We hear about just news from China, and I hadn't heard about it. And in the beginning, I thought, what's that going to be? Maybe this is another harmless, like a flu or whatever. There was a lot of questions around it, but it gave me the creeps, to hear these experts who have spent decades in this field all standing together in the coffee break and being really worried, right? And that's when we only saw a couple of cases early on. And I'm thinking back to this now, and I mean, they really knew what was going on because one of the key people there, Heinz Feldman, who is now running the Rocky Mountain Lab in Colorado or in Montana, actually the biosafety level 4, where you have the most dangerous pathogens. He was super concerned about COVID before we knew it was COVID. And he had worked on the original SARS virus in the early 2000s. And it was part of the delegation that was sent from the US back then to find out what that actually is. Because in the early 2000s, when SARS broke out in China, all we knew was that people were dying and nobody actually knew why. So he was part of this initial team that went to take samples and actually find out what it was, and they identified a coronavirus source back in the day, which was SARS. And now we have SARS-CoV-2, second coronavirus, which is a much bigger pandemic. But so this is just a little bit background. Our yearly symposium, oddly, we talked about COVID, and then the rest is history, as they say. Everything moved very fast in 2020, and we also pivoted in many ways to do research on COVID. So I'll share my screen and show some slides about, let me find them here. Can you see the presentation? Yeah. So I'd like to share a bit what we do, and then maybe open up for a Q&A and a discussion. So you get your questions in, and I can tell you a bit about my own experience with this pandemic. I lead the Henry Wheeler Center for Emerging and Neglected Diseases at UC Berkeley. We are a gift-funded center that has been around for almost 10 years. Henry Wheeler has sadly passed on a couple of years ago, but he was very committed to funding science, particularly in areas where there is no economic incentive to really do a lot of science, because we hand off a lot of the healthcare innovation to the market economics now, and that leaves certain truly important areas behind because of market failure. So Henry Wheeler was very into that, and funded with a donation, generous donation, the center. We're completely gift funded, so we fundraise at different times of the year, and luckily have support from many people, and also from the university that gives us the space, and we are very integrated with the academic environment. So our goal is really, or my goal when I joined, to transform this into a unit that can translate the science done at the University of California into tangible benefits for society. And I'm really passionate about this. I mean, all my professional life, this is really one of the main drivers for me. I've been in a lot of very fundamental basic science, but I think if we have something that could be translated into a product or into a therapy or into some other way how we could organize society better to serve people, this is something we should really do, and we shouldn't hold back. We should have infrastructure in place to support that. And so we started at UC Berkeley really at the basic science and research. We have one of the world's best academic environments, and there's great basic science happening. And every once in a while, there is a truly fundamental discovery that comes from basic science. And then, there's the aha moment, and you realize this is really something you could be using in a medical sense for people. For example, a good example of this was Jennifer Doudna's discovery of CRISPR-Cas9. You might have heard about this. This is a DNA editing technology where, DNA is basically chopped and realigned. And she was initially just studying how bacteria do this, and she was interested in studying the fundamental mechanism, didn't really think about human disease or anything like that. And then it happened, and she had this revelation that this technique, having identified this new mechanism, how bacteria can chop up DNA and realign it, could be useful in a clinical setting. And we now have a whole bunch. I mean, that was a real revolution in the last couple of years. So many applications of that technology. So I'm working in this area, and I believe, translational science has a lot of benefits, clinical for the community. Every company that we spin out generates jobs and really enables a positive feedback loop for the economy that can get started. Innovation is really one of the key drivers of community well-being long-term. So what did we do in COVID? We were very quickly, as this was breaking out, we had the symposium, we were pivoting to COVID-19, and we did it in a variety of ways. I have to tell you, when you look at all this, remember, we are only 3 people in my team. We are a very small group, between 3 and 5, depending on what the students are doing. So the first thing we did was in March, we set up a hackathon, a global event where people could meet on Zoom. This was my first Zoom event, super scary at the time. And we had working groups to develop certain items that we need. One of them was a low-cost open source ventilator. And this company is now active. It's called Respira Works, and they have made great strides. Here you can see the prototype. The idea is to have a ventilator that costs a couple $100 and that you can build and deploy open source in high quality, basically can roll out globally and can be made everywhere. Because I don't know how many of you know this, but the current ventilators are like 40K and up, and for one, and then they're super complicated. I mean, computer driven thing. You need actually a respiratory person that is specifically trained to set everything correctly. And if you use a wrong setting on somebody who is out or something, you can really do some damage. So it's very complex thing. And we were running short of ventilators in the US in some areas, and also globally, of course, huge shortage. This is something happened before the ventilator shortage during SARS in Detroit, for example. I mean, all this came, you know, it's kind of this thing that personally upsets me if we had the problem before and somehow 10 years later, nothing has changed and we have exactly the same problem. So in Detroit, they already did things like they hooked up one ventilator to 4 patients. And so some of these methods were established, but it's not ideal. So one goal is to do something cheap that you can easily build. And they have a prototype and are continuing to develop this. This is a student-led team. It's kind of a group of people, engineers, everybody coalescing around that mission. The other thing we did in the hackathon is shown here is to develop a diagnostic test that is ideally, you know, low cost at home COVID testing. And this one became a finalist for the X Prize, you might know. And here you can see a detection with fluorescence of flu together with COVID and COVID on its own. And this is if you don't have either of them. So it works very well. It's very cheap. It's just a couple of dollars per test. And they also developing it towards regulatory approval. They need to get the FDA to approve the test, but then they could roll it out. It's really simple. It's just these manufactured tubes that don't cost much, and then different layers of paraffin and wax that you poke through with the sample, and then you incubate it at home, and then can read this with a little UV lamp that is part of the package. So that's the goal. A lot of diagnostics going on, but I think this is an important one because it's really cheap and it can be done from home. Again, I could go on for half an hour about why the current reimbursement system and economic system of healthcare doesn't support things like this, which are basically a person directly buying a test kit, right? Although it is from a societal perspective, the cheapest and most efficacious way to do things versus first having to go to the doctor, getting a prescription, going to Quest or some other point, and everybody makes a lot of dough in this process until you finally have your readout. So this would be a better way. We have no good way to currently incentivize this, but this team is pushing forward, and we just got them some clinical samples. Again, interesting story. If you're not in this field, the regulation in this country is just nuts. Access to clinical samples. This team had to get clinical samples from patients from Peru and from Paris, because in the US, nobody wanted to give them clinical samples to validate this, because everybody was afraid of getting sued. And did the patients really consent to having their samples used? And it was super complicated. So this clearly points out also some governmental failures here, because if we have a pandemic, we want everybody to be able to develop diagnostics ASAP, and we should have a central place to provide critical reagents for validation. But the CDC is supposed to do that, but they just failed. So this was one thing, just a little side note, which might interest you because you're all interested in policy. And then the other thing I did was I got really worked up about the fact that as the pandemic was in full swing in early 2020, and Congress passed large funding packages for cruising industry, for airlines, also including research for COVID. None of this money was ever seen in the labs of the researchers. So it just didn't trickle down at all. And the NIH is famously ossified and slow in terms of how they give money. And I saw all these labs ready to roll and do research on COVID, but unless they had unrestricted funding available to just allocate lab funds to buy reagents, for example, they were not allowed to do this and couldn't do this, because if you have a grant from the NIH, from the National Institute of Health, for example, to research cancer, you can't just take this money and go work on COVID. It's not allowed. So they could take away all your funding and punish you. So for that reason, unless you have gift funding from a private donor that's unrestricted or something like that, you just can't do the work. And that was so unbelievable to me. I wrote an op-ed in the local news about it, and in the San Jose Mercury News that got published, because we had every day we lost billions in GDP every day that we had nothing we could do here, no diagnostics and no therapy and no vaccine. But at the same time, the NIH was like nickeling and diming and going, maybe I should give 20,000 for this project, maybe not. Let's do another round of review. And then everything took forever. I mean, they did accelerated schedule of only 3 months review. I mean, that is in an active pandemic absolutely insufficient. So what I did anyway, I got that, as you can tell, I felt passionately about this because it just didn't make any sense. And I went out and raised private money. I got $1 million from a generous donor. And we were able to kickstart 20 COVID projects at UCs and also at Stanford across the Bay Area. We went for UC Santa Cruz, UC Davis, UCSF, UC Berkeley, and Stanford. And like that, we had 20 labs who were doing really critical COVID research, and they were able to kick off and get started with projects while they were waiting on the bigger chunk of money coming from NIH, but just very slowly. So that was very successful. We got a lot of projects funded. One of them was also this diagnostic test. And then thirdly, we work on therapeutics discovery. That's really my area of expertise. I founded, when I joined Berkeley, I founded the UC Berkeley Drug Discovery Center. And we were just in stealth mode doing our first screen before COVID hit. And it was really just in time because we were able to very quickly then execute a screen looking if we can find new drugs that work against COVID. And it's difficult for a variety of reasons. One is you need a chemical library, and I can talk about this later. So we had that ready. And my colleague at Berkeley had access to a biosafety level 3 lab because COVID was classified as a biosafety level 3 pathogen, which made all research on it extremely difficult because you need a special lab that has engineering, the HVAC is totally separate from everything else. It has several, like if you go in, there's like an ante room where you go in first and change into your safety gear, and then you go in. So it's like a high safety bioscience lab, and not many universities have one. We have one at UC Berkeley that's quite well equipped because we have a focus on tuberculosis, and tuberculosis is also airborne, and so that's why it's in BSL-3. We were lucky to have this infrastructure in place, and we could get started right away. And this is also one thing that few people know in the general public, that, for example, for therapeutics discovery, the world leader on antiviral discoveries in the Bay Area, it's Gilead, and Gilead did not have a BSL-3 lab. So their hands were completely tied to work on COVID because they didn't have the lab, right? So this is also, I think, of national importance moving forward, that this changes, because any pandemic agent is likely going to be BSL-3 or 4. And then we can't really, if we can't get lab work done, unless we go through 6 months of permitting, I mean, people will just die. That's the reality of it. So we need to, the fact that even Gilead couldn't do the research is a real national embarrassment. I mean, it took them 6 months to approve the laboratory so they could do the work. In that time, all the academics had already screened what they can. So we were doing therapeutics discovery right away. We kind of pivoted. Here's my colleague Eddie and myself in the lab, and we found compounds making remdesivir 30-fold better, which we're now trying to move forward into animal studies and ultimately into the clinic. So that was an impactful screen, and we published that work. On another note, we also have a global focus. So we have an established collaboration with our colleagues in Uganda at the local university there, and we do a yearly workshop there. And so one of the first things we did was to reach out and see what's needed, because even, I mean, the US was super slow on testing, but in Uganda, it was even slower. And then all the reagents were gone and the PPE was gone. So we mobilized some donors that we work with, Steve Isaacs, the CEO of Aduro Biotech, and Rich Robbins, who runs Wareham Development in the Bay Area. You might have seen they have a lot of buildings. They have a good footprint in philanthropy, really care about Africa. And we were able to kind of quickly mobilize, get a donation of $30,000 together from different sources, and then buy PPE and face shields and testing reagents and send everything over. And they were able to establish the first testing lab for COVID in Uganda with that help, and also with help from their own government, of course. But I have to say, the face shields here you see are manufactured actually in Uganda by a UC Berkeley graduate student who moved there and started a company where they use recycled materials to make these face shields. So we invested in her company to source these, which was really great, right in country, and kind of contribute to the local economy that way as well. We also have at my center a lot of educational activities. We lead projects and programs for underrepresented minorities and women in STEM for more than a decade. We have graduate fellowships we give out, also that named fellowships that donors support. And it's just a couple of $1,000s, but it makes a lot of difference for students being able to afford professional development. Also, we use for computer travel to conferences and things like that, and workshops. All right, and just recently we did the symposium after COVID, and for this one I put on a policy focus. So we did a big session on what can we learn from COVID-19 and the shortcomings that we've experienced on the ground, issues that emerged because of misregulation of diagnostics and therapeutics development, a lack of infrastructure, and how can we influence the dialogue around national security moving forward that is emerging. And we had Janet Napolitano, the former president of the University of California and Department of Homeland Security, Emerita, as a keynote speaker, and she was great. I mean, she pulled all this together into actionable change. And Harold Varmus is a Nobel laureate, and he is in New York right now. They're working on pandemic preparedness, looking at cities as the central nodes to detect incoming viruses. Barry did a lot of vaccine, and he showed me a 300-page report that they had made for the government for pandemic preparedness with 90% of the things I'm telling you suggested as action items, and absolutely nothing was done. So that's all kind of sad story. Like it just got shelved. But I mean, these recommendations, had they been implemented, they would have saved many, many American lives. Right. And then we also had Mark McClellan, a former FDA commissioner, who is now trying to spearhead some public-private partnerships around pandemic preparedness, and what can we do next time around that is improved. Because I mean, we really have shown a harsh light on issues, I think, that we had with diagnostic testing, with some very practical things, the way the healthcare system is organized, and preparedness as a whole. And I think it's critical at this point to take stock and understand how we can use our learnings, as long as they're still fresh, the memory of it is still fresh, to improve the system such that next time we have a pandemic happening, which ultimately scientists know it will happen again, right? It's just a question when. It's like an earthquake, that in that case we can, be better prepared and do better in saving lives as we combat this pandemic. So I think ultimately we need to see this as an issue of national security, because in that world, everybody's been focused on terror attacks and war, of course, but and mechanisms are in place there to make things really more responsive to an emergency. The pandemic thing, nobody really thought about it enough, or no recommendation was implemented. So we don't respond to it like to a national security emergency. We respond to it just like, some new syndrome that is popping up in some people. So very slow. So I think that has to change, and we need to learn from other systems that were previously effective in dealing with rapid threats and moving forward. All right. So I don't know, let me look at the time. Maybe I can just very briefly talk to you about how we found these new compounds that are increasing remdesivir activity. It's a already approved class of hepatitis C drugs, and if you can see here, this is the remdesivir is the only approved therapeutic for COVID right now. On its own, doesn't really do very much in this assay, and then the other drug on its own also doesn't do much. But once you combine them, you get 100% virus death, and it's even at low concentrations. So they really work very well together. And this is our central finding of this one screen we did. And I just have a little cartoon to show you how this really works without getting too much into the details. This is the viral machinery replicating, because the virus has a strand of genetic material, and every time you want to make a new viral particle, that has to duplicate with a high level of fidelity. And remdesivir, the way it works, it's like if you put a foreign coin into a vending machine. So the virus thinks this works, this is the coin, but it's not a quarter, it's something else. So it gets built in, but then it jams it. So at that point, the synthesis is stopped and it's messed up. However, the virus has another enzyme called the proofreader that can basically take this other coin and spit it out of the vending machine again. And so like that, you have a hard time getting a coin in there because the proofreader constantly spits it back out at you. And what we found is these hepatitis C drugs we identified actually, take out this proofreader activity. So when you have that happen, then the remdesivir can go and really act on the virus and much more efficaciously terminate virus viability. So that was it basically. Let me just give a little bit, stop my share, and we can go in a discussion from there. I'm happy to answer questions. Just give you a bit of an overview what we've been up to last year, which has been an extremely busy and intense year for all of us at Send for sure.
Well, thank you, Julia. It's really, really great to hear how hard you're working. It almost feels like you're more of an entrepreneur than an academic, listening
Right.
to the work you've had to go to get people in gear and moving forward. One of the questions that really comes up for me, and anybody who else wants to ask a question, this is a good time to do it. So get your question ready right after mine. There's been a tremendous amount of focus, I think, on the vaccine therapy, or the vaccines as a preventative measure. You've been talking about therapies. What is the difference, and why is that an important distinction? And what should we really be focused on in those areas?
Right. I think both of those, it has to be a two-pronged approach. In order to really, get rid of a pandemic, a vaccine is very, very helpful. And I mean, I'm incredibly grateful they worked so well, right? Because in the beginning, we weren't really clear how well these vaccines will be performing, right? Coronavirus science, people tried to get a vaccine against SARS, and that kind of failed for a variety of reasons. One was that the funding was just switched off immediately after SARS was no longer a threat. And so all this great research that had been done was kind of, basically withering away because the federal funding wasn't spent on it anymore. They kind of went back to diabetes and cancer. So we never really knew if the SARS vaccine would have worked. They had a candidate, but the initial data was pretty crappy. I mean, they thought it's not a great vaccine and it is very hard to get immunity against coronavirus. So in the field, there were a lot of concerns that potentially, everybody knew we have to push really hard on the vaccine, but it could also have been that the vaccines just don't work that well for that virus, right? Because for some viruses, it's very hard to get a vaccine going. We still have a lot of diseases where we have no functional vaccine despite 30 years of research. Look at HIV, for example. So many tries for decades, right? They put billions into this, and we have no vaccine. So that's one thing. But then you also want to develop therapeutics because you always have some people who can't get vaccinated or don't have a strong immune response, right? So they won't get protected. And then secondly, you also want to be able to deal with people as they show up in the hospital. In the beginning, we couldn't really do anything other than, palliative care, basically trying to deal with oxygen, ventilation, and just hoping that they turn the corner, right? I mean, they started to improve treatments over time, but a working therapeutic is a key element here, right? If you can give people something that works, like if they have a bacterial infection, you have an antibiotic that works, then within 1 or 2 days, they're out of the hospital, right? But if you don't have, you're looking at, long things, also several weeks of intensive care and so on. And so, some people make it and some people don't. So you always have to have both. And it's one of these things I think was a real governmental failure. Also, they did really well on the vaccine, but nobody really pushed hard on therapy. I mean, even now, we just have remdesivir, which is a really bad therapeutic. Honestly, if you look at the clinical data, it's not working very well on its own. And that's all we have. And part of it is also, I would say, what led to this was this classification of safety level. Because for vaccine research, you can just do this in your normal lab. You don't need to have a high safety lab because you don't work with the active virus in the beginning. You just, you have the sequence, you make the protein, you start making antibodies, you start making vaccine that way. For the mRNA vaccine, they just needed a sequence. So they can work with the established infrastructure. For this finding therapies, you actually need to grow the virus, right? And because they said research is biosafety level 3, that took out the entire industrial complex from the equation because they couldn't do it, right? So, and this is it's not really appreciated outside my field. Like I never read anything in the newspaper about that. It's like, and I'm still trying to find out actually who does this classification. The CDC makes a recommendation, but as far as I can tell, it's not actually binding. So you could have done something maybe, but so they were ultimately Gilead, all the big players who are really set up to do very fast discovery of new therapies for viruses. They were like had their hands tied because of that safety classification. And then the academics were left to do it. And they often are not set up for efficiency, I would say, or speed, right? I mean, we have infrastructure, but we have very little funds and very little resources. So it's more a manual process in many cases. So ultimately, I mean, people pushed forward and we have several candidates now in development, but it took longer than it should have taken, I think. And given that the researchers working on vaccine normally don't work on therapeutic and vice versa, it's actually not something that takes away resources from each other. You could have just said both full speed ahead, right? And they just didn't do that.
Yeah, it's really kind of interesting. And I want to get to Marty's question, but
Right.
In our laboratories, we were required to have level 3 protection.
Right.
Meanwhile, the virus is dancing around our streets and all we have is a mask.
Right.
It doesn't make any sense.
Yeah, and also in the clinical lab testing. So if you have a diagnostic lab, right, that runs and give, if you get a swab and they test it, the people there, that's all the lower safety level. There's classified as biosafety level 2 with human samples. And had they done biosafety level 3, we could have just not done any testing. I mean, it's the end of it right there. So they had to classify as biosafety level 2 in order to get people actually tested. But it's true that, I mean, you can make the argument if you grow the virus in a dish, you have much higher concentration of virus than you ever have in somebody's swab. So it's a bit more dangerous. But on the other hand, all the people working at this level with viruses, they've had several years of training how to do this safely, honestly. I mean, so if there's a safe place to do this, it's probably in a lab that's already has, constant air exchange. We have biosafety hoods, we have the safety gear. It could have been done a bit more in a relaxed fashion, I think. But in the beginning, it was a bit overkill. I think we see a lot also of avoidance of risk taking in public office, right? Because everybody wants to make maximum safety is number one. But then if you have maximum safety, right, the critical innovation is slow, right? That's just, it's a tension there between these goals, right? It's the same way how you can't win a war with maximum safety as the only the only goal. It just doesn't work, right? And the same is true for winning a war against the pandemic. But it's unfortunate we've all the leaders we have in charge, and I don't even mean like on presidential level only. It's like shocking also in all these expert roles at NIH and CDC, where highly qualified people get moved into very senior positions, and they all just like nobody wants to stick their neck out, right? They all go, okay, maximum safety, right? And ultimately causes problems downstream, but those are very much hidden from the public, right? Because nobody dies, there's no big lawsuit, but we just have, I would say, we deal with the pandemic in a way that is less efficient than it should have been, and people die in the hospitals, right? Because we don't have the therapy soon enough, we don't have testing soon enough, and we can't stop the spread.
Let me go to Marty. Marty, you have a question?
Actually, I have three of them, but I think the first one was mostly answered. I'll just bring it up again, which is, I was aware there was a period when there was lots of remdesivir available, but nobody was being told that it was available. You literally had to ask for it, according to the news stories I heard. I think you've answered that as best you can, but if you have more to add on that one, I'd be interested to hear it. My second,
as a patient, you had to ask for it?
Yes, that was my understanding. That you weren't being offered. You had to know that it was there and you had to ask for it.
Yeah, it's very possible. I would like to see these reports maybe, because I'm just working on a project looking at that, a data science project. I'm curious to see who actually got remdesivir, because we had about 50% of hospitalized patients got treated with remdesivir. And in the beginning, we didn't have enough doses, and it was really limited supply. But I don't know how they made the decision, in the clinic to who got it.
The second question is, when it comes to variants, what is the likelihood, because of the number of people who are refusing to take it or are unable to take the vaccine, that we're going to get a variant that'll either be significantly vaccine resistant or that might be significantly more fatal?
Yeah, that likelihood is there, and that's what keeps me up at night, honestly. I think it's very hard to put numbers on it. I mean, we've seen variants emerge so far. The vaccines hold, right? The mRNA one's particularly good. I mean, we just incredibly lucky. I mean, incredibly lucky that these vaccines work the way they are. It's a completely new technology. Nobody would have thought they work 95% of the time, because FDA said everything more than 50%, we will approve it, right? That's what they said early in the pandemic. So this is really something we have to count our blessings that the vaccines are as good as they are. I think the ability of a variant is definitely there. It could start, and it might not start in the US, but in another country that has no vaccination, right? Because this is a global problem. If you think about variants, I mean, it's something can start in Bangladesh and then spread across the globe, right? Just like we've seen with this starting in China, spreading across the globe. And it's a very scary thought. I would say, luckily for us, in most cases, there is an inverse relationship between ease of transmission and fatality of the virus. So most viruses that kill that they infect are also hard to transmit. So for example, in Ebola, there's one extremely scary strain that kills 90% of people who get the virus. So out of 10 infected, 9 will die. And this is one of the highest fatality rates ever reported. But this virus, you will only get it if you literally hug a sick person or you get droplet to droplet, So it's relatively easy to limit it. I mean, and by just quarantining people. But with COVID, what was so bad, it's right in the sweet spot, between not killing too many people, but still being super transmissible, really, through aerosol. So that's why it spread that way. We haven't seen, I mean, this is in virology a question a lot of researchers are interested in, and we don't have a final answer if you can actually get a virus that is very transmissible and very fatal, which would be horrible, right? Because that would be almost impossible to contain. So lucky for us, the way it is in nature, you normally have either it's super fatal or it's very transmissible, but it's relatively mild, right? So you don't really have a super virus like that. But it's a scary thing, and that's why I think it's so important to look at at vaccination globally. You know, I mean, honestly, it doesn't really matter if we get like 80% of Americans or 85% vaccinated if like the entire country of Tanzania doesn't get vaccinated, because ultimately then it's just going to come from there, right? So I just heard today on the news that they're planning to donate, you know, a lot of doses. The US is planning to donate a lot of doses to this global consortium, and this is good news, I think. So we need to really work on getting it, you know, just making it available now and supporting the cost also somehow that everybody can get the vaccine. You know.
I'd like to go to Rishi, who's had his hand up for a little while, and anybody else. We've got about 10 more minutes to get the questions out.
Yeah, I have a kind of a double question, and maybe it's not even a question, it's the thought to bring up is, I wonder, Julia, if your experience, your knowledge, or your inquiry into like the difference and the history behind terrain theory and germ theory, and how there's this, I wonder what your thoughts are on the battle between them rather than the relationship, you know, not instead of this or that, like what if it's a little bit of this and that, right? So that's the one thing, just bringing it up, because, you know, in Indian medicine, Chinese medicine is so focused on preventative medicine and preventing illness and preventing susceptibility to diseases, whereas Western allopathic medicine is focused on treatment. So I'm just curious about that approach. And then the other thing I wanted to bring up and ask you, doctor, is, with like India right now, I'm with people on the ground that I have family, friends that are out there, the patients who are getting treated with ivermectin are showing incredible results, but that's being suppressed. There's actually just the other day, the Indian Bar Association filed a motion against WHO for suppressing that knowledge that, hey, here's a cheap, it's not regulated by patent anymore. It's been long enough since it won a Nobel Peace Prize. And it's like weird that this like free, super accessible treatment for COVID that works is being suppressed, and even if people share it on YouTube, YouTube takes it down, even if scientists are talking about it and not like talking about it. So I wonder, what do you know about ivermectin?
Yeah.
What's going on?
I know a fair bit about ivermectin. It was reported really early by an Australian team to have antiviral activity, and we tried to reproduce it in my lab. We never saw any antiviral effects. It was completely not doing anything in our hands. So I was a bit critical of and I still am, of the ivermectin, just because we couldn't see that it inhibits the virus in any way. I studied the paper there, it showed activity, but in science, unless you can reproduce things in different labs, people, this is one of the key elements of the scientific method. It should work in several groups. If it's just working in one group, you might look at some other effects. It has been, but they did clinical trial with ivermectin, and it didn't show any effect, I think. So there was some clinical study done. If it's working now, anecdotally, you just have to be, it would maybe be time for another trial. I don't know, in the Indian population, maybe this variant. But the thing that is sometimes hard to wrap your head around is that if you just have a couple people treated and they get better, that doesn't automatically mean that it's due to the drug, right? Because the vast majority of people will get better no matter what. And so you need to do this construct of a placebo-controlled clinical trial with a group of people large enough that you can really tell. So you will have to do maybe 1,000 people that you treat with ivermectin, 1,000 people you don't give ivermectin, and they all come in with COVID symptoms. And then you look if you get better outcomes in the group that gets treated with ivermectin, and only if that's statistically significant you would be able to say it works.
And what's interesting, Julia, I just read an essay about this recently, is placebos tend to work sometimes better because people's like stress drops. They like, who knows what it is. It's not some magical
the
thing.
placebo effect is well known, yeah. And there's also the opposite, the nocebo effect, which is totally
Right.
not. It's like when somebody tells you here's a poison and it's just a sugar pill and you take it, some people actually faint and get really get severe state of things. So we can't explain that currently. Is people working on the placebo and nocebo, but it's not, we don't have a really good model how it works. But it's still the gold standard for determining efficacy is the clinical trial. And the ivermectin, I mean, you could argue that, it's possible. I think people have burned their fingers a bit with the hydroxychloroquine, right? Because there it was similar. And hydroxychloroquine actually in our hands showed antiviral activity. It just doesn't work in people. But there they first pushed hydroxychloroquine and gave it to people, and then people started self-medicating with hydroxychloroquine. And then you saw actually fatalities because it can introduce heart problems if you take too much. And there's this famous couple that just bought it online and took it as a preventative, and they died because of heart arrhythmia. So with that, I think the FDA became a lot more cautious about just recommending to take something that's not really proven, because you have to weigh that against the potential risks of taking the drug. If you had a drug that only had upside and no downside, is perfectly safe, like let's say healthy diet, right? Or something like that, or eat your vegetables, you would always recommend it because there's really no risk associated with it. And if it works, great, right? If it doesn't work, well, then you've had a healthy diet, right? But with ivermectin, I think they're a bit reluctant because the data is very mixed. The positive data is anecdotal. There is no clinical trial data that's positive. Certainly in our hands, it doesn't work in the lab.
Could that also be like a financial issue, that not getting funding, not getting support, not getting structural support?
Right. I mean, that definitely is a problem currently. I mean, the trials are extremely expensive and difficult to do also. So it's a couple of reasons, not only the money, it's also in an active pandemic. I mean, there's chaos in the hospitals. The last thing the doctors need is some other guy like wanting to do another, you have to do all the paperwork and you have to enroll the patients and so not everybody, when people are dying, like in New York, when they were completely overwhelmed, you just can't do that. But money is also a problem. Yeah. So currently the NIH channels all this, and they do this program called Active, where you can submit, for example, a drug that you think might work, like ivermectin. You could submit a proposal and say, here's some data supporting that ivermectin works, and they would actually run a trial for you for free to check if it works. But so that's there. NIH, I mean, my personal opinion, they are notorious for picking the wrong compounds. I mean, that's just the thing. They centralize everything. They just don't have a great track record of picking winners. So they put sometimes a lot of money into things that don't work. And then some other things you just like, why the heck don't these people get funding to do the trial, right? So that is the problem with this, I would say. But in principle, we have infrastructure and we have funding there from the NIH to do these trials. And currently they're completely overloaded with cases. But the ivermectin, I mean, ultimately, if they think there's activity, they're just going to give it to people, the doctors, because they have the right to just do that off label, right? If the doctor and the patient agree, you can take ivermectin and see what happens. But it's also an infectious disease drug for worm infection, right? We have actually, this is another thing, super neglected. We have not many drugs for worm infections. Ivermectin is like the only one almost. And so they also want to make sure they don't use it broadly, and then maybe you generate worms that are resistant, and then ultimately you have nothing for the worm infections. So it's a little bit that calculation too. But if people are really desperate and you have hospitals failing, like it was in India, I think ultimately everybody is just going to try everything they can get their hands on, right? And there's going to be a black market, and you're just going to try.
maybe Julie, we all just need to drink more wormwood, some absinthe, and we'll get rid of the worms the natural way, you know?
Maybe that's it. Yeah.
Julia, we have time for just one more question, and Mark Fagoni's had his hand up for a little while, so I want to do one more before we close the meeting, if that's okay.
She just answered my question. It was about the hydroxychloroquine. She just answered my question. Thank you.
Let's take it from Steve then. One more
I
from
got a
Steve.
real quick question. Julia, have you been vaccinated?
Yes, I've been vaccinated, and
Which one?
I got the Pfizer
Okay,
BioNTech vaccine, and it was so surreal when I got it. I just felt like a huge sigh of relief. I mean, I'm like, finally I could see light at the end of the tunnel. Yeah, we got relatively early because we actually working on the virus, right? So everybody who's working with the virus in the lab, they had priority. It's like clinical lab personnel.
I wonder if you would weigh in on this, because a really good question was asked by Terry about our upcoming get together for the first time in a year and a half. Since his children are not vaccinated, should Terry be concerned going to an event where one or two people are not vaccinated? What advice would you give Terry? Should he just?
How big is the event?
How big is the event? 25 people to 35 people. Outdoors.
Outdoors. I think that, I mean, my personal opinion is that's fine. I'm not aware that we actually ever had any transmission cases outdoors, really. I mean, the local government completely overreacted on the outdoors thing. I mean, the fact that state parks were closed in California, this doesn't make any sense. The play structures were closed, also doesn't make any sense. Parks were closed, no. I mean, no tennis that's ridiculous. So I think it scared people, really. That's what it did, because everybody goes, well, the park was closed. So, if somebody goes running and they pass me 5 meters away, it's got to be dangerous. But it's not. I mean, we know no single case that I'm aware of transmission of COVID without vaccination, right? Just plain transmission outside. I mean, it's all indoors, and there's certain high risk activities you should avoid. Like singing in a choir is one of the worst. But but outdoors I think is fine, particularly if you're vaccinated. I mean, even if you one of these very few people where the vaccine isn't working very well, it still works in a way that you won't die, right? I mean, the progression of the disease is much milder if you get it and you've had the vaccine.
All right. Well, we have so many more questions. One question just came in on gain of function. We've got a whole list more, but it's 1:32 p.m. and technically I need to end the meeting.
Gain of function virus. So you think if it's if it's a really horrible variant, then we would have to reconsider recommendations. But if we really had a horrible variant right now, then we probably would know. We would know, I think. I would say outdoors fine. It's more a psychological thing. Frankly, it feels really weird getting together with people again, and then also no mask. It's kind of odd. I think we all have to get used to it again, and be comfortable with it,
Well, Julia, I just want to express appreciation on behalf of the entire club for your being here today. It's really been a delight to listen to you. You've got a very fresh, honest approach. And unlike so many of the conflicting messages we've had from NIH and CDC and every level of government, every time you hear a new message, you fail to trust it. Become an issue. And when I listen to you, I feel like, well, this is someone I can listen to and really have a conversation with and take seriously. And I really appreciate your approach on all of this. I'd love to have you back for more, because I've got a list of questions we never got to, and I know everybody has some.
Yes. And also feel free to reach out with some questions. I've been doing this informally, particularly with vaccine concerns. Some people, there's a lot of unusual news out there, and it's very difficult to gauge from a scientific perspective what's good reporting and what's not, because what I've seen often is, in some of the more controversial pieces, they actually pick out like 60% of truths, so it looks real, but then the key element isn't there to really put it in perspective, so it's misleading, right? So I've seen many of things like that. As scientists, we get really trained to spot this, because it's part of analyzing scientific literature. You have to be really follow it through. But I've given advice on questions there in an informal way with the other clubs I'm involved with, like the California Rare Fruit Growers, where I'm a proud member, and also my band, which have some, a lot of seniors in the band because it's a big band. And there's also a lot of concern there because we're working, brass section and so on. So there's a lot of airflow. And how do you make that happen, right? So it's people are concerned, and I think certainly depends where you are online, but it's very easy sometimes you go into like a pocket where if everything sounds super scary, but some of it is not real, right?
Mm-hmm.
Right.
Well, thank you
Julia, you're
again.
wonderful.
Thank you again. Thank you to everyone for coming to this meeting. We look forward to the next one. And again, Julia, thank you so much. It's really been a pleasure to sit down.